All right, finishing up this second unit, we're on to the examples. So the examples determine the unit vector notation for the following vectors. So it just wants us to convert coordinate form into unit vector form. And if you make the changes to your note, the harpoon is extremely tough to do in the SmartBoard software. So if you want to help me out with that. So probably way too much space left here on your handout. But all we're simply doing is we're just converting this to the partnered unit vector form. So this vector, and I'll draw out the first one for you, make it very painful, but this vector u is -9, so -9, and up 12, there's the 12. So this is what that vector looks like. So remember that unit vector form is like a road map. So I need to go -9 steps back on the x-axis. So 9 tells me how many steps, negative corresponds with the direction on the x-axis. Then I got to go up 12 units, so plus 12j. There you go. That's it. That's all there is to converting it, and that's all that question's really looking at. So just making a quick conversion from the coordinate form to the unit vector form. All right. So speeding it up, what about 3D? Well, we would go positive 3 steps on the x-axis. Then we would go positive 5 steps on the y. And then this is a 3D vector, so the value for the z-axis is k. So the unit vector for z-axis. So just again, these are not arbitrary. Okay, these are the standard. I, j, and k are your standard 3D unit vectors for the x, y, z axes. All right, that's all that's involved there. Take the following in ordered pair notation. So this one's going to take a little bit more thinking, but nothing that you haven't seen before. It's just a combination thereof. So I'm going to drag the first one out. So vector u is 20 units north. So north, east, southwest. North 20 degrees west. So that means I'm facing north and I rotate 20 degrees to the west. So there is my vector. So that's vector u. Now, key here, never, ever, ever, ever do we want a measurement with the y-axis. We always want it with the x-axis. So we do not want the 20 degrees. We actually want the 70 degrees. Okay, we do not want the measurement with the x or the y-axis, always x. So now, this is the part where I'm going to drag it out. If I create a right angle triangle here, which I'm going to, I want to know my x value and y value to go into coordinate form, because the answer here is going to be vector u equals my x and my y. So let's look at that triangle specifically. So here's my vector u, which I know is 20 units in length. Here's the x value, my y, 70 degrees. So how do I solve for x and y? You're just going to use SOHCAHTOA. So if this is my reference angle, I have opposite, adjacent, hypotenuse. So to find my x value, I'm going to use a and h, so I'll use cos. So cos theta equals a over h. Do my substitution. Cos 70 equals x over 20. 20 is the magnitude of the hypotenuse. Rearranging it, my x value is 20 cos 70. So there's the x value. The y value, I need to find the opposite side, so that means I'll have to use sine. So sine theta is opposite over hypotenuse. Sine 70 equals y over 20. Y will equal 20 sine 70. Don't even have to pull out a calculator because calculators aren't permitted. Why waste time calculating? That's why we have the other types of universities that I won't label online. So we know that in ordered pair notation it's x, y. Well, we just found x. That's your 20 cos 70, comma, and your y is your 20 sine 70. Oops. And I got to start using square brackets. It's been a while. So there we go. So there's your vector u. And yes, it's always in that form. So down here, on your cheat sheet, this is what you want. So for ordered pair notation, and this is going to become second hat after a while. So vector u equals xy, or if we don't know the end coordinates, this 20 that I got from the example is the magnitude of the vector. So it's the magnitude of u, and it's cos theta, and it's always cos for the x coordinate. The magnitude of u, sine of the theta. Okay? And it's always in that order, so you don't have to continue, or you don't have to always go back and do this. I said I just did this process here to show you the steps, but that's all that's really necessary. Oops. So, number B here, or letter B. So now that we know that, it doesn't matter that the angle is over 180. So there's the answer there, cleaned up a little bit. So vector V is simply magnitude of the vector, cos of the angle. So cos 230, comma, 50 sine 230. Now some of these are going to be positive and negative values. And that comes from your cast rule. This is an afterthought. Okay, 230 degrees happens over here. So tan's positive. So both of these coordinates would be negative, which tells me that those values would be turned into a negative value. So that's how you end up with something in quadrant 3. Okay? But that's the answer. Final answer is this right here. You don't have to go any further than that. All right. Last example, I believe. Well, I got to have a quick discussion after that. So determine the magnitude, direction, and unit vector for the following. So in this case, we'll go through this quick, and you can slow me down when necessary. So determine the magnitude. So first of all, magnitude of u is always equal to the square root of the x component plus y component squared. So that means I would have 2 squared plus, and yes, you need to use brackets. Okay, and I'm going to show all the steps on this first one. 4 plus 36. I expect people to do that without a calculator with little difficulty. So root 40 units. The direction. Now here's something that's interesting with the direction. For this vector, again, I'm just going to sketch it the first time for you. 2, negative 6 is where the vector is. So 1, 2, 2, 3, 4, 5, 6. So somewhere down here. This is the angle I want. I know that the length on this side is 2. I know the length on this side is negative 6. So how do you find theta? Well, to find the angle, so theta would equal opposite adjacent hypotenuse. If I know A and O, that means that I'm going to be using tan. So tan, I guess I'll try not to mess everyone up here. So we'll start with opposite over adjacent for TOA. So we're looking for theta. So it's the tan inverse. O over A, negative 6 over 2. So theta would equal tan inverse of negative 3. We have no calculator. So there's our direction. Okay. So there's the direction. And finally, the unit vector. The unit vector u is equal to the original vector divided by the magnitude of the vector. So 1 over root 40. So that's the 1 divided by unit vector, and then multiplied by the original vector. So 1 over root 40, that's the 1 divided by magnitude, and it'd be 2, negative 6. All right, now the textbook distributes it in. Okay, I don't really care for you distributing it in. It's more work, and it's not going to gain you anything. So the textbook does distribute this value in, so when you check your answers, they've done it, but this is all I want for test purposes. That tells me everything I need to know. So there you go. There is magnitude, direction, and your unit vector, all wrapped up in one. Okay, so on to the third example here. So shrink this down a little bit. Okay, magnitude of V. So magnitude of V, this is a 3D vector, and I talked about it earlier. X squared, Y squared, Z squared. So 1 squared plus 3 squared, 9 squared, 1 plus 9 plus 81. So that gives me square root of 91. So there is my magnitude. The unit vector of V is the V vector over magnitude of V. So 1 over root 91 multiplied by 139. So there's unit vector. And direction for a 3D vector, this is where you use your directional cosines. So with the x-axis, it's going to be cosine inverse over 1 for the x value divided by the magnitude, root 91. For the y-axis, it's going to be the cos inverse of 3 over root 91. And the last one, beta, cos inverse of 9 over root 91. Again, no calculator, so this is where you leave it. So these are final answers here. So you have magnitude, unit vector, and in this case, this is the direction of that vector. So you got to give it in terms, it's kind of like Star Trek for the Star Trek fans out there. Okay? They give 3 coordinates on where to drive the ship or sail the ship, and that's it right there. Those are your 3 coordinates. All right. And do I have time to finish this up? Let's try, because I think it's just a quick discussion. And somewhere the homework is this here. There it is at the bottom, yeah. Okay, so 3 space. We can break areas into planes. So if you label these quickly, so X, Y, and Z, X, Z, Y, X, Z, and Y. So if I include the x-axis and go in the direction of Z, so I'm going to be careful how I draw this. So I'm going to draw a parallelogram with its sides parallel to the X and Z plane. All right, this is what we call the XZ plane. It's just a piece of paper that all X and Z coordinates would fall on. So that would mean that when you want a coordinate on this plane, it would be the X value. Y would always have to be 0, and then Z coordinate, because we can't leave that piece of paper. So that blue represents a piece of paper, and it's oriented so that it's sitting on the X and Z axes. Okay. If I draw it parallel to the Z and Y, so it goes something like this. Now this piece of paper is kind of straight up and down. So that means this is what we call the XY plane. And a coordinate on the XY plane would be X, Y, and you can't leave that piece of paper, so the Z coordinate would always be 0. And the last one, I need to draw it. It's got to be the YZ plane. This is where the people who have spatial skills and artistic skills pull away from the rest of us. So it's straight up and down. So that means that that piece of paper has all the possible Y coordinates and Z coordinates, but you can't leave that piece of paper, so X would have to be 0. So there's one question about that in the homework, and this leads us into the second unit. So getting your head around what 3 space looks like and talking about a little bit about planes, but that's more of a conceptual question. So the homework here is way down at the bottom for you. Okay, go through, try the homework, and if you have any trouble, let me know, and I will give you a hand getting it fixed up. Good luck.